Oops, did that in one of my last videos. Let me see. The last time I tried to share the screen. Let me see here. Here we go. All right, everybody. I had to cut the last study session short. I apologize for that. But I have C# homework that I need to get done today. Yesterday, I did end up getting my HTML homework turned in. I ended up staying up really late to get it done, but it's all turned in. So now I have my C# homework that I got to complete today. So we are just going to be covering the, it looks like a lot of the if-else statement and, well, it's all right here. The bool, variables, flags, logical operators, all that good stuff. So I'm going to get right into it. I do just have a couple windows open that I need to close out of. I don't want to close out of the wrong one. Okay. So here's what we're going to be working on. Decision structures, the if statement, nested decision structures, logical operators, bool variables and flags, comparing strings, preventing data conversion exceptions with the try-parse methods, input validation, radio buttons and checkboxes, the switch statement, introduction to list boxes. So quite a lot. All right, decision structures in the if statement. A decision structure allows a program to perform actions only under certain conditions. In code, you can use the if statement to write a simple decision structure. Familiar with that from when we were covering JavaScript and learning JavaScript a little bit, so it's not completely unfamiliar, which is good. To write a simple decision structure. A control structure is a logical design that controls the order in which a set of statements execute. So far in this book, we have used only the simplest type of control structure, the sequence structure. A sequence structure is a set of statements that execute in the order that they appear. For example, the following code sample is a sequence structure because the statements execute from top to bottom. So we have int, age in years, age in days, age in years equals, okay. Although the sequence structure is heavily used in programming, it cannot handle every type of task. Some problems simply cannot be solved by performing a set of ordered steps, one after the other. For example, consider a pay calculating program that determines whether an employee has worked overtime. If the employee has worked more than 40 hours, he or she gets paid extra for all hours over 40. Otherwise, the overtime calculation should be skipped. Programs like this require a different type of control structure, one that can execute a set of statements only under certain circumstances. This can be accomplished with the decision structure. Decision structures are also known as selection structures. In a decision structure's simplest form, a specific action is performed only if a certain condition exists. If the condition does not exist, the action is not performed. The flowchart shown in Figure 4.1 shows how the logic of an everyday decision can be diagrammed as a decision structure. The diamond symbol represents a true-false condition. If the condition is true, we follow one path which leads to an action being performed. If the condition is false, we follow another path which skips the action. So we have cold outside, true, wear a coat, false, then it will go to the other decision. In the flowchart, the diamond symbol indicates some condition that must be tested. In this case, we are determining whether the condition cold outside is true or false. If this condition is true, the action wear a coat is performed. If the condition is false, the action is skipped. The action is conditionally executed because it is performed only when a certain condition is true. Programmers call the type of decision structure shown in 4.1 a single alternative decision structure because it only provides one alternative path of execution. If the condition in the diamond symbol is true, we take the alternative path, otherwise we exit the structure. That's it. Otherwise we exit the structure. Figure 4.2 shows a more elaborate example where 3 actions are taken only when it is cold outside. So we have multiple options here. We have it's cold outside, true, wear a coat, wear a hat, wear gloves. So you have a few more steps if it is true that you need to take, and then false. In C#, if you use the if statement to write a single alternative decision structure, here is the general format of the if statement. So you have if, then you have your expression, and then you have your conditions and statements right there. The statement begins with the word if, followed by an expression enclosed in a set of parentheses. Beginning on the next line is a set of statements enclosed in curly braces. The expression that appears inside the parentheses is a Boolean expression. A Boolean expression, which I also remember when I was learning about JavaScript, that is familiar to me. It's a true or false statement. Is one that can be evaluated as either true or false. When the if statement executes, the Boolean expression is tested. If it is true, the statements that appear inside the curly braces are executed. If the Boolean expression is false, however, the statements inside the curly braces are skipped. We say that the statements inside the curly braces are conditionally executed because they are executed only if the Boolean expression is true. If you're writing an if statement that has only one conditionally executed statement, you do not have to enclose the conditionally executed statement inside the curly braces. Such an if statement can be written in the following general format. Okay, so just like that, if it's only one, you don't need the curly braces. When an if statement written in this format executes, the Boolean expression is tested. If it is true, the one statement that appears on the next line is executed. If the Boolean expression is false, however, that one statement is skipped. Although the curly braces are not required when there is only one conditionally executed statement, it is still a good idea to use them, as shown in the following general format. So we have that example there of just proper formatting. This is a good style for writing if statements because it minimizes errors. Remember, if you have more than one conditionally executed statement, those statements must be enclosed in curly braces. If you get in the habit of always enclosing the conditionally executed statements in a set of curly braces, it's less likely that you will forget them. Okay, moving on to Boolean expressions and relational operators. Boolean expressions are named in honor of the English mathematician George Boole. In the 1800s, Boole invented a system of mathematics in which the abstract concepts of true and false can be used in computations. Typically, the Boolean expression that is tested by an if statement is formed with a relational operator. A relational operator determines whether a specific relationship exists between two values. For example, the greater than operator determines whether one value is greater than another. The equal to operator determines whether two values are equal. Table 4.1 lists the relational operators that are available in C#. So a lot of these are the same as JavaScript. We have our greater than, less than, greater than or equal to, less than or equal to, and then are not equal with the bang symbol. The following is an example of an expression that uses the greater than operator to compare two variables, length and width. This expression determines whether the value of the length variable is greater than the value of the width variable. If length is greater than width, The value of the expression is true, otherwise the value of the expression is false. The following expression uses the less than operator to determine whether length is less than width. Table 4.2 shows an example of several Boolean expressions that compare the variables x and y. So we have, is x greater than y? Is x less than y? Is x greater than or equal to? And so on. All right. Two of the operators, greater than or equal to and less than or equal to, test for more than one relationship. The greater than or equal to operator, which we have here, determines whether the operand on its left is greater than or equal to the operand on its right. The less than or equal to operator determines whether the operand on its left is less than or equal to the operand on its right. For example, assuming the variable A is assigned to 4. Oh my gosh. Assume the variable A is assigned 4. All the following expressions are true. So if this is 4, it's going to be true because they made it that it's either greater than or equal to. The equal to operator determines whether the operand on its left is equal to the operand on its right. If the values of both operands are the same, the expression is true. Assuming that A is 4, the expression A is equal to 4 is true, and the expression A is equal to 2 is false. Note, the equality operator is two equal symbols together. Don't confuse this operator with the assignment operator, which is one symbol. All right, and then we have this one. Operator is not equal to operator. This one is the not equal to operator. It determines whether the operand on its left is not equal to the operand on its right, which is the opposite of the equal to operator. As before, assuming A is 4, B is 6, and C is 4, both the A is not equal to B and B is not equal to C are true because A is not equal to B and B is not equal to C. However, A is not equal to C is false because A is equal to C. Putting it all together. So this is the following example of an if statement. If sales is greater than $50,000, bonus is going to equal 500. This statement uses the greater than operator to determine whether sales is greater than $50,000. If the expression sales is greater than $50,000 is true, the variable bonus is assigned 500. If the expression is false, however, the assignment statement is skipped. So this shows a flow chart for the section of code. So that's what happens. The following code sample conditionally executes 3 statements. All right. So we have if sales are greater than 50,000, bonus is going to be 500. Commission rate is going to be 0.12. And then you met your sales quota will be the message, the output. All right, and then this is how that would look. When you write an if statement, Visual Studio automatically indents the conditionally executed statement as shown in the previous examples. The indentation is not required, but it makes the code easier to read and debug. By indenting the conditionally executed statements, you visually set them apart from the surrounding code. This allows you to tell at a glance what part of the program is controlled by the if statement. Most programmers use this style of indentation when writing if statements. Oops. So we have our first tutorial. We're going to be completing the test score average application. In this tutorial, you complete an application that allows the user to enter 3 test scores and calculate the average of the test scores. If the average is greater than 95, the application also displays a message. Let me see if I can go ahead and open that. All right, so we're going to load up Visual Studio. I'm going to see if it will let me share my whole screen. And then I have to just download the source code really quick. I think I actually already have it downloaded, so I don't want to download that again. All right, I'm just trying to organize some of my files so that I can start on this little project. Okay. So let's see. Source code, test score average in chapter 4. Let's see where that is. All right, chapter 4. I'm actually not seeing that in here. Yeah, I'm not seeing that project. Huh. Not seeing it. All right, well, I'm going to see if I can share my Visual Studio screen. So this is what we have here. And then let me open up my see if I can open up my video.
Really?
All right, so I do have a video tutorial that I can follow along with. I'm actually going to see if I can share that whole window. Or the entire screen, I guess. So I'm just going to move that to the side. Here we go. So I don't know what happened with the, let me see if I can go back and find that project, because it's supposed to already have been started. I mean, it looks familiar. I wonder if it's in a different folder, because it's definitely not in the chapter 4 folder like they said. So let me see. Okay, so I have the source code. I have chapter 4. So we have grader 2 and grader 1. And I wonder if that's the, I'm just going to kind of look through these really quick and see. Okay, nope, that's not the one. Your test score, your grade. Okay, so I'm thinking maybe it's listed under grader 2 then, because that's grader 1. Grader 2 is the one that probably has the average, I'm guessing. Open our form. Oh, I guess not. It looks the same. All right, let's see. I'm just going to check back really quick in the other chapters just to make sure it's not in there. Yeah, it's definitely not listed anywhere. Huh. Interesting. I mean, this kind of looks like what we want, but not exactly. Why is my camera open? Weird. Yeah, it doesn't exactly look like what we want. All right, well, we'll just see what he does here. I do remember this being talked about in, I think, the previous chapter where they calculated averages. So that's what makes me kind of think that maybe there was a template in there, but I wasn't able to find it. So I don't know. It was not in the files, and I checked on all of the files. I checked in all the folders, so I'm not sure where I would get that. I might need to reach out to my professor about that, but this one was definitely not in there. And there's only 4 folders there, 4 chapters available. So I'm just gonna go really quick, go back to the source code again, just see if I can download that. Okay, this one actually looks a little bit different. Okay, I found it. It's here. Maybe the other one was just, I don't know what was going on with that. That was so weird. Okay, well, I wasn't able to find it, so I'm gonna go ahead and open it. Okay, and close out of our empty window. This project file or web cannot be found. What? I might need to update something. I might need to update something. Okay. File could not be located because it's in. All right, so some technical difficulties are happening here. Gonna go ahead and completely close out of that. And this is kind of annoying, so. Okay, let me see. All right, I'm gonna take a look and see what's going on because I want to at least do this, go through this exercise, and then I'll probably end the stream. But definitely running into some difficulty. I'm just going through and deleting that one source code file that I had, and then I'm just going to completely re-download it and see. Okay, so that is gone. Don't have anything in my download folder now, so I'm going to go back and see if I can install them. All right, almost all set. got a lot to copy over. Maybe the last time that I didn't, maybe the last time I downloaded it, it just didn't copy everything over, is what I'm thinking. I thought it was pretty weird that I only had like 4 chapters in there too, so something was definitely going on with that. All right, almost done. Let's try it again. Nope, it only has 4 chapters. Again. That is so weird. It's just not copying them all over for some reason. I think I might have figured it out now. There we go. Now it's showing all of them. All right, let's see if it will open now. Here we go. Now it's working. Okay, finally. That took forever. Finally, all right. That only took about 30. That only took about 30 minutes. Okay, let's see what we have here now. Okay, so this is where we have to code in everything for our that's going to be our high score. High score value. My gosh, I'm struggling. Cannot type. Can't type, can't talk. And then we have our double, which is test 1, test 2, test 3, average. And that is going to be variables. And then we have the test scores, the text box, boxes, and for test 1, that is going to be double dot parse test box, test 1 box. The same for test 2. And test 3. This is how we're getting our different test scores. Okay, I think we're all good there. And then we're going to put our calculation. So calculate average test score. And that is going to look like average equals, we're going to use our parentheses to calculate this part first. Test 1 plus test 2 plus test 3 divided by, of course, 3, since there's 3 tests, and that's what is going to bring us the average overall. So here we are going to display the average rounded to 2 decimal places, and that is going to be calculated this way. Average label. Use our toString method. Putting in N1 here. What I like about this is that you can hover over certain things and it will give you a little description of what that is, which is pretty cool. And then if we're going to set up our if statement, if the average is a high score, congratulate the user with a message box. So we're going to do if our exception average is greater than, and then our high score. We're going to put out our message box. And then our message. Congratulations. Great job. All right, so it looks like we're going to put an error message up for the catch block. So I'm going to go ahead and follow along here. Message box. show, and then X message, which we're going to set up. Okay, so for the clear button, that's going to be clear the text boxes and the average label. I guess I should put in a proper way to write text boxes. The average label control. So we have test 1 box text. And then this is our clear, how we clear that box is with our 2 parentheses there. And we'll do the same for test 2. And with our little parentheses. And lastly, or for the last one, it's our average label. Looks like that is it. Oh, it's going to be focus. I'm changing that to the focus. Okay, let's hear what he has to say about that. All you have to do is put this and then close to close the form. Okay. All right, so to run it, you just press the start button. And it looks like we have cannot implicitly convert type string to system.windows.forms label. Gotta figure out what that means. Hmm. I'm not sure what happened there. Maybe with this one? I think it might be. Yeah, I just forgot to put text right here. Okay, now it should be all set. You gotta have good attention to detail, otherwise things don't run properly. Okay, so now it should do what we want it to do. And if we try and test it out and put 85, 85, 85, our average should be 85. And it is. We're going to clear that out. And what if our average is 95, 100, 65? And we get our little message box popping up. So cool. Looks like it works. All right. I love when I actually get to do the hands-on portion and test things out because it's a lot of fun. I'm going on about an hour now. I'm going to go ahead and save my project. And since this is week 4 that I'm on now, I'm going to go ahead and add a new folder, week 4. And this one is going to be our average test calculator. Okay, so that's all I'm going to do for now. And then I will be finishing my C# homework today. I also have some e-commerce homework that I need to complete. And then I might go live next week. Hopefully I'll be able to go live more during the week, but we'll see. It just depends on how busy I am. But all right, hope you guys are all doing good, and I will see you in the next one.